Hi, today we're going to talk about the E6B, the wind side. The wind side of the E6B doesn't perform as many of the calculations as the other side does. However, I feel it's just as important in your flight planning due to the fact that it calculates your ground speed, which is used for your time en route, which in event is used for your fuel requirements, which are pretty important steps with the flight planning. So the wind side is an important aspect of the E6B, and today we're going to go over the wind side. So we're going to go through the components of the wind side. Here I got a little diagram kind of blown up to kind of give you a better look at it from just the little E6B here that I have that I'll be using for calculations later on in the presentation. So we'll start with the components of the wind side of the E6B. We have the rotating azimuth, which is on this sliding grid. Now the sliding grid has two sides. The lower speeds are at the bottom, the higher speeds are at the top. Just give you kind of demonstration so you can see what. So this is the sliding grommet here. We got low speeds. It starts at 30 knots. All the way to 260 knots. Now these straight lines are the course correction angles, left or right of the center line. These arc lines or speed arcs. For example, this is a 70 speed arc here, 90 speed arc here. So for example, this 20 degrees left of the center line at 100 knots would give you your course correction angle there, 20 degrees, which is a little confusing as I'm talking about it, but as we go through the problems it becomes a lot more easier. Nextly, we have the wind correction angle scale, which is fixed. It does not rotate with the rotating azimuth. We got our true index, which is used for putting your true course or your wind directions under the true index as you're rotating it there. It also has instructions for finding ground speed and true heading, which come in handy from time to time. As many times as you do this with your flight planning, I'll still take a peek at the instructions from time to time. It also has instructions for determining true heading, magnetic heading, and compass heading, which is, at this stage of your training, you could look at it like a review every time you go to do one of these for your flight planning. You got, your true course, left to right of your wind correction angle equals your true heading. Either east or west variation will give you your mechanical heading. Mechanical heading plus or minus the deviation for that particular compass card will give you your compass heading. So that are the basic components of the wind side of the E6B. Now we'll start going into the different types of problems that you can do with this side of the E6B. The different type of problems you can do is obviously your heading and ground speeds, which are always used with the flight planning. A couple other things you can do with the wind side, which I haven't done a lot of, is finding your exact winds aloft or unknown winds. For example, in-flight calculations, not typically done with a helicopter pilot, but fixed wing, in-flight calculations, as far as an example of would not be having a GPS and wanting to know your winds and speed of your winds so you can better calculate your time en route and turn your fuel requirements there. So we'll go and I'll show you how to do that on the E6B, finding your unknown winds or finding the exact winds aloft. And you can find your most favorable winds with the E6B. That type of stuff would be used for altitudes and with given altitudes the wind speed and directions will change, so you can plot from the winds aloft forecast the different wind direction and speed and plot for different altitudes, and then use your true course and decide what's the best altitude to fly at. So I'll briefly go over that too with you and show you how to do that. So the first thing I like to go over is finding your true heading and your ground speed. Now typically the 6 components that you're always going to use when you're using the E6B or finding your heading and ground speed are going to be your true course, your true airspeed. So you're going to use your true course and your true airspeed. You're going to use your wind direction, you're going to use your wind speed, and that's going to give you your heading and ground speed. So we'll do a sample problem here for finding your heading and ground speed. Okay, for example, let's say we have a true course of 239. So we got a true course of 239. You also need to know, like I said, your true airspeed. In this case, we'll have a true airspeed of 98 knots. So with the true airspeed in knots, we look at our winds of law forecasted for the time of our flight, and at our altitude we have a forecast of 100, winds are from 100 degrees true, and they are forecasted at 15 knots. Now with this information, using the E6B wind side, we can determine what our corrected heading and our ground speed is going to be. For that, we're going to go ahead and pull out our E6B here. I'm going to do my best to, hopefully you can see this. So we start off with, we set our wind directions under the true index. So we know our wind direction is at from 100. So 100, put this on backwards. Okay, so we put 100 under our true index with our rotating azimuth here. So now that we have 100, which is our wind, where our winds are coming from, we put a mark up from the center grommet of 15 knots, which is our wind speed. So you can use any scale here, it doesn't matter where it is, for this particular part here. So 10, 2, 4, 15 knots our wind. Now I'm going to put a mark there with my pencil. You're going to use this mark, so you got to make sure it's visible. You don't want to lose it wasting time with that. So now that I got my 15 knots, we're going to set our true course. Our true course here is 239. 239. So now that I have 239, I'm going to use my true airspeed of 98 knots. Now the mark I previously made, I'm going to move that up to the 98 knot speed arc. Should be right about there. Now once we put our mark at our 98 knot true airspeed, we're essentially done with this. Now we just take the information off the E6B here. So we can determine by looking at where our mark is from our grommet, we can determine that we have a left tailwind, and so we can assume or know that our ground speed is going to be faster. So we look at underneath the grommet, which is the center, is the ground speed. So it looks like we have a ground speed of about 109 knots. So our ground speed is going to be 109 knots, and we have the wind correction angle of about 5 degrees to the left. So what that translates into is subtracting 5 degrees from our true course will give us our wind correction angle. So I always do subtract 5 degrees, but it's 5 degrees to the left. So there, we solved the problem from our true course and our true airspeed. We got our winds aloft, and we found that our ground speed is going to be 109 knots, and our wind correction angle is 5 degrees to the left, or subtracting 5 degrees from true course. And so that's basically how to do your ground speed and true heading with the Windside E6B. Now I'm going to go into, like I mentioned earlier, the unknown wind. Now this is important to know how to do. The fact that the FAA requires you to know it on some of the knowledge exam tests. There'll be a few questions regarding this, being able to do the calculations with the E6B here. So for that, we'll erase the board. So you have to have some information to be able to perform this with the E6B. You have to have the true airspeed. In this case, let's say it's 95 knots. You have to know your ground speed. Let's say that the ground speed is 87 knots. True heading, 085. So we got our true heading 085. We have our true course at 105. We have our true course at 105. Now, automatically I like to decide what our wind correction angle was, and we can do that by our true course and true heading. So our true course is 105, our true heading is 085. That's a difference of 20 degrees. We look at subtracted, so it's basically to the left or subtracted 20 degrees is our wind correction angle. So with this information, we can determine where our winds are coming from and the speed of the winds. So to do this, we need to start with our, true course. So our true course here is 105. So we put our 105. We got our true course of 105. Now we put the center grommet, it's kind of backwards here doing it this way, but now we put our center grommet on our ground speed of 87 knots. So I have the center grommet on 87 knots. I have the rotating azimuth under the true index of our true course of 105. Now I want to find our true airspeed arc. True airspeed is 95. So I'm looking for 95, the arc on 95 on the sliding speed here. 2, 4, we got 97, and I know that I got a wind correction angle of 20 degrees to the left. So that's left of the center line. This is subtracted. So I find 20 degrees. I also find my true airspeed of 95 knots. It's right about there. So now I made my dot from the arc of the true airspeed of 95 knots and the 20 knot wind correction angle. Now I slide that until it's above the grommet, right above, it's on the center line above the grommet. Now that gives me where the winds are coming from. Winds are coming from 020 at 32 knots. So that'd be 10, 20, 30, about 32 knots. So with the E6B, we just found where our winds were from and how fast our winds are, the speed of the winds with this information. Now going back to the other calculations we can do with this is finding our most favorable winds before flight. Okay, just briefly want to go over this. Let's say we have a winds aloft forecasted, say 3,000 feet, forecasted at 180 at 10 knots, 6,000 feet, and forecasted at 87 at 17 knots. So this is just a quick example of winds aloft forecast, 3,000 feet at 180 at 10 knots, 6,000 feet we got 187 at 17 knots. Now we would simply put our grommets at our predicted, let's say our predicted true airspeed of 110 knots. So we plot, we go to 180. So we're basically plotting our winds aloft on the E6B. So we got 180 and we're at 10 knots. So we put a mark there and we can put, I like to put 3,000 right at that mark. So now we'll go to 6,000 feet and we got 187. So that's not too far. 187 at 17 knots. So that's about there. So that's 6,000 feet. So we have two different marks on here. We got 3,000, we got 6,000, according to what our predicted winds are going to be. Now we want to go to our true course for the flight. When we go to our true course, let's say our true course is 320. Now, knowing that our true course is at 320, we can look at these different winds aloft at 3,000 feet, at 6,000 feet, and determine which winds are going to be most favorable for us. Most favorable would be higher ground speed, less wind correction angle, etc. And so that's how you use the E6B to determine your most favorable altitudes for flight. Just a quick calculation, see what, like I said, altitude is going to give you the best performance. So essentially those are the functions of the E6B, the wind side. We went over how to find heading and ground speed, also finding the exact winds aloft and the most favorable winds for your pre-flight. So that's the E6B, the wind side. If there's any questions, please let me know. Thank you.